Welcome back to the DevVlog. It's been a little while since I've made a video like this, and I was inspired to play with some IK. I've always liked IK, and one of the projects that I'm working with here at school, they need some IK, and I thought I would just experiment with what's built into Unity to do 2D IK, and there's some stuff in there. So let's check it out. First, I decided I wanted to get some tentacles to like animate, and so I grabbed this. I did a little searching on the internet, and I found this. This is some pretty good tentacle stuff, and the person who made it here, FieraRyan, made this available under public domain. So, you know, props to them for doing that. Let's shoot them some support. All right, I downloaded and cropped that first tentacle. And let's just create a core 2D project. This is just an empty 2D project using the standard renderer, nothing fancy. Which version are we in? We're in 2022.3 at this point. Okay, yeah, let's delete that. This, first of all, I made my own tentacle. And this is why I am not an artist. This is why I don't do my own art. Okay, let's take that good tentacle that that we found, and let's see what we can do with that. So there's our tentacle, and we want to explore IK. What is IK? IK is a type of animation that is calculated instead of pre-authored. So let's explore how to do that. Okay, we're going to start with the Sprite editor. Bring that over here where we can see it. This is your standard Unity Sprite editor, but up here in the corner, there's a skinning editor. So we're going to make a series of bones going through our tentacle and use them to move the tentacle around so that we can animate it. Okay, let's create bones. I'm going to say the base is right here. Okay, I remember last time I also had trouble creating my first bone. I'm going to double click. Okay, double clicking. Now I'm in bone creation mode. And so I'm going to click, hold, drag to make a bone. Oops, not just click, drag. Okay, so click and then drag to the next bone. And I'm just going to make a series of bones going through my tentacle. To the end point. There we go. And then when I'm done, I'm going to right click to terminate the chain. Okay, so I've just got some bones going through there. I want this to be very flexible and very smooth. And so let's subdivide that geometry. I'm going to take the subdivision and max that out. And then you hit this generated. Bum, 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 bum. Okay, and I'm going to want auto weights generate. And normalize. Okay, the rainbow of colors here shows you which bone is weighted to which one, and I wish I could smooth that more. I mean, I could if I paint, right? If I paint, like, let's see here. If I paint bone 2, can I paint on these? It's not letting me do that. Is it? Oh, it is. It's just sort of gentle. Okay, so yeah, let's see if we can smooth these bones out a little bit. Okay. I'm just smearing them more in between the bones to make it softer so that it's not sudden. I want very smooth curves. Not kinky corners. I want very, very curvy corners. Okay, I'm going to say that's probably pretty good. Let's get bone 1 down in here some more. Okay, let's try that. I'm going to apply. And these are the bones that are going to bend my tentacle. Let's check it out. Let's put a tentacle now in the scene. Now, I had been watching somebody else did this and they automatically got all the bones. I'm not going to get the bones automatically, but if I add a Sprite skin onto my thing and create the bones, clickety, brink, the bones come in and I'm all set. So let's see how smooth my bones are going to look. Zoom in here a little bit. If I bend one. So let's just grab one in the middle here. How many bones do I even have? Okay, so let's grab this bone right there and let's rotate it and see that, yeah, I wish it was even more curvy, but I could continue fiddling with that later. But I can bend now in any of those bones. All right, cool. So we could create animations for this. We know how that works. We call it FK, or forward kinematics. To make IK, we're going to go on here, and I'm going to the root object, and I'm going to create a component, and it is going to be an IK manager. IK manager 2D. Okay, there's your IK manager, and I'm going to want an IK solver. Now, the limb solver is good for like just doing arms and legs where you just have the two bones that are bending. For a longer one, you want a chain. And for my tentacle, a chain CCD is the classic. Okay, the CCD, all these IK things need two things. They need a target. That's the thing your object is going to reach out for, and the effector, which is what is the point that is being reached with. So for the effector, we want the tip of the tentacle. I'm going to say the very tip of the tentacle is going to try to grab something. Okay, so let's add something there. We're going to add an empty game object, and I'm going to call that effector. Okay, and let's put it, this is going to be where the tentacle tries to grab. So I'm going to put it like not quite at the end, just right there. Okay, and I'm going to need a target, so I'm going to add one on this sub-object. This is the target. And let's give that an icon. Let's give it like green on a show up nice. Green icon. Let's give it like a circle. Okay, there's the target that the thing's going to reach for. And it's going to reach for right about where we said the effector is. Okay, now let's fill those in. So the effector goes in there and the target goes in there. Boom. So there's some other settings here. The chain length. The chain length for the CCD is how many bones participate in this effort. So I want all of them except bone 1. I don't think I want this first one to rotate, because that's when I'm going to like anchor it to my object. So I think I don't want that one to rotate. I want all the others to rotate. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. So I want 9 bones to participate. And they're in green there. Oh, looks like I miscounted. Indeed, there's one more. Let's make it 10. There you go. The green dots show you which ones are going to rotate. All right. There we are. And we can, in scene mode here, we can see how this works. If I grab the target and just move it around, we can see what we're talking about. The IK solver is going to try to bend all the pieces to make it so that the tip can reach the end point. And that works pretty good. But there's problems. You can see it pops and snaps. Pop, 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 pop. Right? And I want it to move smoothly. The real trick to make it move smoothly is to just turn this solve from default position, turn that off. What that means is if with this on, it restores it back to default position and then bends it from there to get to where you need to be. But if you want to have something that's dynamic and moves, you want it to solve from wherever it ended up. So let's turn that off and see now as I drag how it moves more fluidly. Cool. And you also see if I drag to where it can't even reach, it'll just do its best. It'll point at it. Okay, so that's pretty tentacle-ish. Pretty tentacle-ish. I like that. It's not bad. Other things you might want to play with. There's a lot of settings on here. The CCD algorithm is iterative. It goes down the chain trying to solve the rotation of each joint as it goes down. And it's not perfect. And when it goes down the entire chain, it's not going to be perfect. So it can do iterations. Like it'll do one, refine it, do another one, refine it. And you can see, I can tell it how many iterations I want to allow. I actually want to slow down the motion of the tentacle a little bit to make it seem more alive. And so let's just turn the iterations down to 1. I don't need it to be perfect in a single frame. And so I'm going to save a little processing time and just not devote it all to there. And that might make it lag a little bit if I move really fast. Mostly it takes it a while to sort of unwind the kinks when the kinks get in to the shape, and that's okay. What else can I do? Here, the weight. I've noticed that the weight, if I turn it down, let's turn it way down here, that's going to make it sort of not get all the way to it. And that can create a sort of living look to the thing. So that may be a little bit low. I felt like 0.2. Let's try 0.2. Oops, I didn't mean to move the solver around. Let's move the target. And now it's got a little bit more slowness to it. Okay, what else is on here? There's a velocity. I can turn the velocity down, and that might give it a little bit more of that slowness that I'm looking for. Like it's reaching after you, it's following. Cool. Okay, and so the last thing I want to do is I want to play this in the game, and so I've got some little scripts. Just got a finger drag script. I'm going to throw that on my target. I'm going to save my scene. Let's hit play. Finger drag target is going to do what you think, which is when I click, it's going to just follow my mouse. And so you can do whatever you want with this tentacle procedurally and programmatically. Let's do this. Let's take the target off of the object. Make sure it still works. So now I have a target. Going to my finger. Okay, and let's make a prefab out of that. A tentacle. Make a tentacle prefab. Oops, tentacle. Give me another one. Let me space them a little bit. Okay. We gotta have 4. Let's have 4. Let's have another one. And let's space them out a little bit more. Make them look a little bit more natural. Okay, here we go. Oh wait, they all have to be set to the target. I only set the one to the target. Each one has a solver and each one needs a target. So we're going to put the target, same target for each one of them. They're all going to try to get me. Here we go. They're all reaching for me. Look at that. Isn't that creepy as heck? Okay, how about if we take some of these tentacles and, oops, didn't mean to do that. I'm under the tentacle itself. Let's have them coming in from over here. That one reached me from over there, and let's take this one, tentacle over there, and let's have it reach from that side. Wow, maybe it's going to reach from like the top of the screen over here. Okay, let's try that. Look at that. Isn't that amazing? Isn't that incredible? That's pretty cool. Very, very disgusting. Okay, so yeah, that's some cool stuff you can do with IK. And obviously, I'm just having it follow my finger. But what else could you do with it? You could do just about anything you can imagine with this thing. If you don't want them all to reach exactly the same, you might give each one its own target and have the target follow this target with some kind of random walking noise on it, and have them all be a little bit different. Like make them, you can give each one sort of a wavy behavior on top of your target, so each one kind of reaches for it independently. Cool. And if you want, like, actually the group that is wanting to use this didn't want this slow response that I was trying to get. They wanted a more sudden, sharp action, like a punch. So we're just going to crank those up. And hold on, let's make sure I saved it. Did I save it? Yeah, didn't I save it? Yeah, and so now if they want to do a punch, you'll just take the target and whack, 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 whack. Just move the target very suddenly to the way you want it to. Like maybe they'll coil up and attack. Coil and attack, right? So that's some pretty cool stuff you can do with the tentacles. All right, hope you guys enjoyed that. I had some fun with it. Let's review. Oops, we reviewed how you can set up bones on a sprite, and you can use this to animate the sprites right here in Unity. And what we're doing with those bones that are on the sprites is setting up an IK chain. We did that by putting a sprite skin, first of all, on our sprite object and creating the bones. And then we added an IK manager, 2D. And it does need, right here, you can create new solvers, different kinds of solvers. Limb solver, fabric solver, or what we used is the chain CCD, the CCD solver. This is the classic cyclical descent, chain cyclical descent, something like that. That's what you normally would think of. And then on that solver, you give it a target, you give it the effector, the grabber point is the effector. What you want to reach for is the target. And then you can fiddle with your settings to get the look that you want. All right, hope you guys think that's as fun as I think that is. I've always liked these. You can do lots of different things with it. It doesn't have to be a tentacle. It can be, a snake coming up from a snake charmer's basket. It could be, the tail of a cat. I've used it for the tail of a cat before. Anything you can imagine that you want to programmatically control a curve, you can now do this, and it's super duper easy. Thanks for watching, and let me know down in the comments if there's anything else you want to talk about. See you out there on the DevVlog.